I will also start a recording on the Zoom, so we'll just make sure. Okay.
Recording in progress.
All right, let's get started. All right. All right, guys. So basically, it's really Q&A. You can just ask your question here. You can type on the chat, or you can just ask me. You can will speak up. You can ask me anything about the lectures or labs, etc. All right. Question. Palm, go ahead, please. Hi. Go ahead, please.
I had a question regarding the lecture of February 26th. I believe it's page 3.
Page 3. Okay. You said February 26th.
That's right.
Oh, just from today. Okay, sounds good. Yeah, of course. Last week, last Wednesday, and then iPad notes. You said page number 3.
Um,
Sure. What about it?
Sorry, it's the next page.
Next one. Sure. What about it?
I think one more. Sorry.
One more? No problem. There we go.
Yes.
Yes.
So, like, there's a question saying formulate the deadlock freedom.
Mm-hmm.
I didn't understand this part quite well. Is it possible to explain it?
Of course. Absolutely. Just give me one moment. Just about the formulation, right? Over here. Okay, good. So what I will do is let me just take a screenshot just for this guy here. And then I'll put it on the page and then we'll talk about it. Yeah, just give me one moment. Okay, let me switch to iPad here. All right, good. So basically this one here, when we talk about deadlock freedom, right, for label transition system, so we are supposed to like a model, like a reactive system. So that means you should make sure it's always the case that you can always make a progress from some states. So you can think about for reactive system, from each states, it's always possible to make some progress. And of course, here, when we say progress, that really means you can make some transition. Okay. So what we do is, if you consider just any state S over here, right? Just any state. It can be a start state, or can be somewhere in the middle, just state S. So when we quantify over S over here, we're just saying that S should be a member of the set of states as part of the formal model, right? Remember, it's a triple. And then we're saying that for every state, it is always possible for us to make a transition, to make a progress. So from S over here, we can just make a transition, and then it's going to be transition into S prime. And S prime itself is also a member of the set of states. And then we're saying that this transition over here is actually possible. Okay. Transition possible. And there's simply just different ways to really formulate this. So we said that, for example, from the source to the destination, from source to destination, it would be a member of the transition relation, right? We say that transition relation is simply just from the source to the destination, right? We're just saying, for example, let's say the transition relation is going to be a set of states. And then we're saying that somehow S and S prime is simply one of the pair that actually exists over there. That means it is possible to at least make a progress from S into S prime, right? Does it kind of answer your question, or you're more interested in learning about 2, 3, or 4, something like that?
Yes, I get this part, but I'm a little confused about the domain restriction.
The domain restriction over here?
That's right. That's right.
Sure, no problem. So what we're saying here is, so if you look at here, so let's say S prime over here. Okay, let me just write it down. So here we say S prime should be in the range of, so we're doing domain restriction to just S. And then that's the domain restriction symbol. And then that's the transition relation. Okay. And then, okay, like that. Okay, let's now try to understand this expression here. So this one here is a relation. That's a transition relation. So this is a relation. And then after applying the domain restriction operator, so this will be just another relation. Whose domain is just whatever we restrict that into, which will be just S. Let's say, for example, okay, let's say you may have, let's say the transition relation here. I'll just make it up very quickly. So you may have S0 that can go to either S1 or S2. And then from S1, let's say it's a self loop, it will only go to S1, right? Let's say a very simple transition relation. And this one here just correspond to, we got S0, which can go to either S1 or it can go to S2 over here. And from S1, you can go to S1 itself. For S2, we don't, let's say we can get stuck. Okay. So let's say here, if you try to do domain restriction, right? Let's see one example here. So if I put if I put, let's say, S0 over here, and the relation that's going to return back to us is going to be all the pairs whose first element is actually S0. That's the domain value, right? That's the first value. So this relation here is going to give us S0, S1, and also S0, S2. Okay, that's what we'll get as an example. And once we have got this one here, we know that the source S0 can either transition to S1 or S2, right? And now we are saying that S prime that we are talking about over here is simply one of the possible destination states. That's what we're saying. We say there exists at least one S prime. S prime here can be, for example, S1 or it can be S2, as long as it's a member of. So S prime over here, you simply just cannot say, okay, not yet. Okay, so let's say this one here. So that's the relation we have. If you simply say, for example, S1 is a member of, this is not valid because you can see this is a single state, but each member here is a pair of states. So we don't really have the compatible types just yet. So what you want to say is, you want to say what you want to say instead is something like here. So if you look at this, the range of the S1, S0, S1, and also, oh, sorry, let me just make sure that's right. Okay, so we got two pairs over here. We got S0, S1, and also we got S0, S2. Okay, the range of that is just going to contain the the second value over here, S1, S2. That one there is going to give you just S1, S2, the range. And we're saying that here, for example, S1 is just a member of that, right? Apparently it is. So that means S1 is one of the states where S0 can transition into. And in the actual quantification, we're saying that as long as there's at least one state from which you can to which you can transition from S over here, that will be fine. Do you think it's better?
Yeah, I understand. Thank you so much.
Very good, no problem. I think this one is important here. We're just saying at least one state, but apparently this one here, it will satisfy because from S0, at least one state, it can be either S1 or S2. On the other hand, you can see this transition relation here is not deadlock free because let's say S2. Let's say if you got S2 over here, you can see S2 does not have any transition, right? So that means it's not deadlock free. Okay.
Perfect. Thank you so much.
No problem. Okay, I'll just make a note over here. This one here, no progress can be made. Alrighty, Okay, next question, please. Yeah, guys, just in case you want to ask like how many questions there might be in the actual test, I don't know yet because I might reuse maybe some question from the previous year, but the coverage was not exactly the same. The last time I taught 4315, so I may have to redesign, design some new questions. But if I can know a little bit more, maybe I can mention that briefly on Wednesday's class. Okay, but you can definitely just go over the materials that's covered. I think that'll be your safest bet. Yeah. Yeah, if you got more question, put on the chat, or you can just speak up, and then we'll discuss. Okay. Is there another question? So you guys are okay? If you guys need to take more time to collect a question, you can do that. And then I still got office hour on tomorrow, Wednesday, as well. I'll wait a little longer, just in case. Okay.
Sorry, Professor.
Go ahead, please.
Sorry, can I ask what are we expected to learn for this written test from the lab? The
Right.
general form, or like even the questions that we did for programming test one are covered?
So I think for let's say for lab one specific, let's say for lab one, of course you gotta review, the concept one. The bottom line, you will not be asked to really write a whole algorithm in Pascal or write a very complicated assertion, right, in the actual written test. But you might be asked to maybe fill out the blanks, like what I said in the guide. So in this programming test, you are not expected to memorize the syntax for the algorithm like a while loop or if statements. You don't need to. However, you should be familiar with the Pascal or TLA plus syntax for assertion, okay, as I said in the guide. So you might be asked to write certain parts of the assertion as the precondition or postcondition. That might be something you will be expected to write. But it's not going to be like a lot, but there will be some fragment you have to know how to write just for the assertion part. For lab one, you may want to review about the different concepts, especially the ones we kind of talk about in the highlights in the lecture. And then, for example, we talk about variance versus invariance, and we talk about how you can encode the variance in the model, and also other things like a reachability graph, things like that. Right? That's about the labs. Okay.
Thank you, Professor.
No problem. Is it possible to ask to write a formula given the leftmost derivation steps? Yeah, it's possible. You might be given a string, and then I would say what would be step number 5 if you do the leftmost derivation, right? That could be one, or it could be that what we said earlier, like last time. Let's say if I give you the parse tree, and then I say, okay, now consider some particular part of the subtree, and then what will be the corresponding steps in the leftmost derivation or rightmost derivation, things like that. It's possible. I would say anything that we kind of discuss in the class, that's something I would expect you guys to know. Okay. Okay, guys, I'll pause for one more moment. But you still got office hour, right? Tuesday, Wednesday. All right. All right. Anything else? Okay, I'll pause for one more moment. If you guys really have no question, there's no problem. You can maybe collect more questions and then we can discuss them still before the test. I'll pause for one more minute.
Hi, Professor.
Yeah, hi, go ahead.
Can you please explain the labeling function again?
Labeling function? Yeah, of course. The labeling function, I think, let's now
It's
go
on
back.
the same slide.
Yep, sure. Of course. The labeling function, let me just go to the slides there. Maybe I'll go to the here. Oh, right here. Okay, good. Right. The labeling function is right here, right? So that one there is basically from one state into a set of atoms. Okay. For example, let's say over here we got three states, right? You can see we got S0, we got S1, and we got S2. And we got two atoms. We got x larger than 0 and x larger than 4. So each propositional atom is going to evaluate either to true or false on each state. And the labeling function is going to take a single states, right? It can be taking S0, it can be taking S1, or it can be taking S2. So if you apply the labeling function to the single states, it's going to return the set of atoms that's going to evaluate to true, right? So for example, let's say for S0, we assume that x will be equal to 2. That's a variable. And in that case, we know that x larger than 0 is going to evaluate to true, but x larger than 4 is going to be false. So the set of satisfying atoms will just be x larger than 0. It's only a singleton set. On the other hand, in S1 over here, the value is assumed to be -1. In that way, both atoms will be not satisfied. So that's why you will see empty set over here, and etc. Does that kind of answer your question about the labeling function?
Yes, it does.
Okay,
Is
awesome.
it different from transition relation?
It's different. Well, transition relation simply tells you if I am given a particular state, like what I said earlier, right? Transition relation tells me if I am given a state, how can I move to another state? Labeling function is to say, given a state, I want to know what are the properties that will hold true on that particular state, right? It's different.
I see, that makes sense. Thank you.
Okay, you're welcome. All right, guys, final call if you got any more questions. All right, if no further question, we can end the session earlier. That's okay. As I said, I still got my office hour. You guys can welcome to drop by, or if you want to catch me very briefly after the class on Wednesday, I can also do that. All right. All right, thank you so much. And I think I might just make the recording available for your fellow student later. All right, take care, and then I'll see you later. Be well.
Recording stopped.